Hello guys, I'm Prakriti N from CSEI. Today I'm going to present about continuous distribution, the normal distribution, the central limit theorem and p-values, confidence intervals, which comes under the subject called data science and applications. Introduction to continuous distributions. Continuous distributions are mathematical models that describe the probability of a variable taking on any value within a given range. They are fundamental in statistics and data analysis, providing a powerful framework for understanding and analyzing real-world phenomena. Normal distribution has the iconic bell curve. The normal distribution, also known as the Gaussian distribution, is a fundamental probability distribution characterized by its symmetrical bell-shaped curve. It is a continuous distribution that is widely used in statistical analysis and modeling. Key properties of normal distribution. The normal distribution is defined by two parameters, the mean, that is mu, and the standard deviation, that is delta. These parameters determine the location and shape of the curve respectively, enabling the distribution of model a wide range of real world phenomena. Widespread applications. The normal distribution finds extensive application in fields such as finance, physics, biology, and engineering, where it is used to model various processes and phenomena. Its mathematical properties make it a powerful tool for statistical inference and decision making. Properties of the normal distribution are symmetric, unimodal, tails, and standard deviation. So symmetry, the normal distribution is a symmetric bell-shaped curve with the mean, median, and model all coinciding at the center of distribution. Unimodal, the normal distribution has a single peak or mode, uh, which represents the most frequently occurring value in the distribution. Tails, the tails of the normal distribution curve approaches the x-axis asymptote, never quit touching it, indicating that extremely high or low values are possible but very unlikely. Standard deviation, the standard deviation determines the spread of the distribution with approximately 68% of the data falling within one standard deviation of the mean. The central limit theorem. So the definition of central limit theorem is, it states that as the sample size increases, the distribution of the sample means approaches a normal distribution regardless of the underlying distribution of the population. Importance. This theorem is fundamental in statistics as it allows us to use the powerful tools of normal distribution analysis such as hypothesis testing and confidence intervals even when the original population distribution is unknown. Applications. The central limit theorem is widely applied in fields like finance, engineering, and social science, where researchers often need to make inference about population parameters based on sample data. Sampling distributions. Central limit theorem. The central limit theorem states that as the sample size increases, the sampling distribution of the sample mean approaches a normal distribution regardless of the shape of the original population distribution. Standard error. The standard error is the standard deviation of the sampling distribution of a statistic, such as the sample mean. It measures the variability of the statistic approach across different samples. Hypothesis testing in sampling distributions are the foundation for hypothesis testing, as they allow us to determine the probability of obtaining a particular sample statistics under the null hypothesis. Hypothesis testing and p-values. Null hypothesis. So null hypothesis is, hypothesis testing begins by starting a null hypothesis, which claims about a population parameter that we want to evaluate. So second is test statistics. So we then calculate a test statistic, a numerical value that summarizes the sample data to determine how likely the observed data is under the null hypothesis. So next is p-values. The p-value is the probability of observing a test statistic at least as extreme as the one calculated, assuming the null hypothesis is true. Decision: if the p-value is less than the chosen significance level, we reject the null hypothesis and conclude the data provides evidence against it. Confidence intervals. Definition of this confidence intervals, let's see. So they provide a range of likely values of an unknown population parameter based on a sample statistic. So interpretation: a 95% confidence interval suggests that there is a 95% probability the true parameter value lies within the computed range. Applications are widely used to estimate means population proportions and other populations. Characteristics in fields like marketing, finance, and healthcare. So confidence intervals can be used, or its applications can be in finance and healthcare and also in marketing. Practical applications of confidence intervals. So confidence intervals have numerous practical applications in data science. They allow us to quantify the uncertainty around parameter estimates, enabling more informed decision making. For example, confidence intervals can be used to assesses the effectiveness of a new medical treatment by providing a range of uh, pl- uh, possible values for the true treatment effect. Similarly, confidence intervals can be used in market research to estimate the proportion of customers who prefer a particular product feature, helping guide product development. Limitations and assumptions of normal distribution. Assumptions. Normal distribution assumes data is continuous, symmetrically distributed, and has no weakness or outliers. Limitations. Normal distributions may not accurately model data with heavy tails, multimodality, or nonlinear relationships. Robustness. Many statistical methods are robust to minor violations of normality, but extreme deviations can significantly impact the results. In summary, we have explored the key concepts of continuous distributions, the normal distributions, the central limit theorem, hypothesis testing, and confidence intervals. These foundational statistical principles have widespread applications in data science and beyond. Thank you.